CFT Live.
Attenzione passeggeri, siamo arrivati.
Attention passengers, we have arrived.
You hear that, young scientists? I made it to Parma, Italy. I'm so excited. I took a boat from the port of Alexandria to the port of Napoli. Then I took a train all the way here to Parma. Today, we're going to check out Parma, visit a few museums, and check out the National Gallery. I can't wait to meet up with Sarah and check out the cool art pieces. Let's go! Hey T, you ready to go? Am I ever? Wow. Whoa, T, are you okay? Yes. I think the emissions from that car messing with my lungs.
Yeah, unfortunately, a lot of cars create emissions. Emissions are substances like liquids, heat, sound, light, radiation, and gases that are released into the air from a specific source. In this case, the emissions are greenhouse gases, which are fumes that are released into the air from combustion engines in cars.
They smell bad and hurt my lungs.
Yeah, sorry T, I'm gonna go find something to help soothe your lungs. Let's meet up again in 3 hours.
Okay, bye Sarah. Thank you. Whoa, that gas is really hurting my lungs. Oh my goodness.
Did you say that the gas is hurting your lungs?
I sure did. That car. Wait, who are you?
Well, I'm Esther.
Okay.
Hi, I'm Karina, and we're friends from SCU. We work at Chiesi.
Oh yeah, I do know you. You both gave a great lecture about respiratory health.
That's right, and I remember you.
And hey, when we went to SCU, we ran a demo on asthma. Do you know what that is?
Yes, I actually remember it quite well. Asthma is a condition that affects people's lungs. Asthma affects people who live with it in different ways. Some people's breathing problems may come and go, while others may feel a similar kind of shortness of breath that reminds you of a person who has a cold. Remember, you both told us that people with asthma may wheeze and they might feel a tightness in their airways, or they might even cough.
Many times this happens because airways get swollen, narrowed, or are even filled with mucus.
And asthma affects every person living it in different ways, but there are scientists that work to help with common symptoms.
Ah, yes, biomechanics.
Exactly.
Biomechanics.
But I remember that word, but what are biomechanics? Everyone seems to know what that is besides me.
Well, biomechanics are the study of forces acting on biological systems.
Oh.
Imagine trying to play a trumpet.
Okay, I could do that.
When you try to play a trumpet, you need to take a deep breath in and then blow. When you just try to breathe in, what did you feel in your body?
Well, I did feel my lungs fill up with air, and my chest kind of puffed up a bit too.
Exactly. The way it works is that your lungs have muscles around them, and that helped them get bigger. What happened when you breathe out?
Well, blew some air out, and I also felt my chest lower.
And that's because your lungs release the air. The muscles around them relax, so your lungs got smaller. That's the part of biomechanics. Figuring out how your muscles help your body move and work, even on the inside, like when you're breathing.
That's right. When you inhale, your lungs are expanding, which means that the muscles around them are getting bigger. And when you exhale, your lungs are contracting, which is the diaphragm and the rib muscle relaxing. It reduces the space in your chest, making your lungs deflate.
Oh, cool. Well, what are you doing in Parma?
Well, actually, Chiesi is based in Parma.
That's so exciting. I love how that you all are based in many different locations. The various locations mean that people from all different kinds of backgrounds are able to build upon the work that Chiesi does and is so important.
That's so kind of you.
It's important to us that we foster as many perspectives as possible. We want to dispel the myth that scientists look or act one particular way.
That's right, because I'm a scientist and so are you. We may be the same in a lot of ways, but we're also different. And that makes us unique, special, and able to come up with many different solutions. Like that time that Sarah, our TA, and I made that bridge in China. We were only able to put that together because our different perspectives helped us come to a solution.
That's what being a scientist is really about, using our different perspective to solve a singular solution.
Anyone can be a scientist.
Can you scientists show me around Parma?
It would be our pleasure, and our colleague Michelle will join us.
Excellent. All right. Thanks for showing me around Parma, you all.
Actually, team, we're not done yet.
You're not?
No, we have a super fun experiment for you.
That's awesome. Okay, let's get to it. I'll let Sarah know that I'm heading off with you guys. Sarah!
Hi, my colleagues Esther, Karina, and Michelle sent me over with the supplies for this really cool experiment. My name is Chimamwe.
Hi Chimamwe, it's so great to meet you. I'm Sarah. Now T went off to explore Parma with your colleagues, which means I'm going to get to tell her all about this experiment. She and I love experiments. I can't wait. So what are we doing today? What are our materials?
All right, so today we're going to need 3 straws, 3 balloons, some Play-Doh, some tape, a plastic bottle, a pair of scissors, and we're going to use all of this to make a DIY model of our lungs.
Amazing. Oh, I see. Okay, so this is going to be like the demo that our friends at Chiesi showed us. They explained to us that this is an experiment that models how the lungs work. So that means each material is going to represent a different part of our lungs. So the straw is going to represent the trachea. Can you tell me about that?
Yeah, exactly. So the trachea is also often called the windpipe, and it carries air in and out of our lungs.
Oh, okay, so this in our neck. So then that means that this plastic bottle must represent the rib cage, the bones that protect up our lungs, right?
Exactly, yes. This part of our chest is called the thorax, and it also includes the rib cage and your lungs.
Interesting. Okay, so that means the balloons must represent the lungs, but I count 1, 2, 3 balloons. We only have 2 lungs. What's that third one?
Exactly. So the third balloon represents the diaphragm, and the diaphragm is the organ in our body that moves air in and out of our lungs specifically.
I see. Okay, so now we've got all that background information, so we know what we're working on, and now let's get ready to build this thing.
Great, let's go.
Okay, so the first thing we're going to do, young scientists, is we're going to have a trusted adult help you to cut the bottom out of a water bottle. So you can do this with scissors, with a knife, but again, we're going to ask that you have an adult help you with this part. That's all you need is just a plastic bottle with no bottom. So we've got that all set up. And now we're going to start with just sort of exploring that last thing you were talking about, the diaphragm. Because I feel like a lot of us have heard of lungs before, but the diaphragm's a little bit different. So I think the first thing we're going to do is we're going to take one of our balloons. You pick the color.
All right, the yellow one.
The yellow one, perfect.
Yeah.
We're going to take the balloon, and without putting any air in it, we're just going to tie a knot at the end of the balloon as if it did have air in it that we were trying to keep in. Because in a sense we are. So we've got our little knotted balloon, and then we're just going to cut the top off of this balloon, and this is going to be a diaphragm. So the diaphragm is below the lungs?
Yes, exactly. So it's actually a muscle in the lungs. So what happens is, underneath the lungs. So what happens is signals are sent from your brain to the diaphragm, and that helps tell the diaphragm when it needs to either expand or relax to allow air to go in as we breathe in or out. And once we do the experiment, we'll go through that information.
Amazing. Okay, so I've got the top cut off of the balloon. So now for our diaphragm, we're going to stretch open the bottom of this balloon that we just cut. And Chimamwe, if I could ask you to hold that, you can help to have 4 hands here. We're gonna stretch this over the bottom of the bottle so that we have this sort of nice seal around. And then because this has to be airtight, right, we need to have air moving, we're gonna use our tape just to sort of help support that seal and keep it together. So I'll just put some tape around these edges. So this is kind of all about air pressure and moving air in and out, right? So this must be a pretty old part of our body. We must have a lot to learn about here. Okay, we've got our tape balloon. Okay, so now we're gonna take just one balloon as a sort of representative of just this sort of interplay between the diaphragm and the lungs. So we're gonna take one balloon and we're gonna put the balloon inside the bottle but leave the top out, and we're gonna put the opening or the neck of the balloon around the neck of the bottle. So I'll show you how that works.
The purple one?
Purple, perfect. So we're going to put the balloon in, we're not gonna drop it in, we're gonna leave the little top out and then stretch the top of the neck over the bottle. Okay, I think we got that. All right, and now we're gonna know if it works, right? Because if it does, we should see some air happening.
Yeah.
So you said that the brain signals to the diaphragm telling it to expand or contract. So as we,
there we go.
Yeah. So as we pull down, we can see that the balloon inflates.
Exactly. And so what's happening here is that as you pull down, the diaphragm expands, which allows a lot of space to be created in the lungs, and that allows for air pressure to move from where there's a lot of air pressure, which is outside, into the lungs where there's less air pressure, which is like all human beings do. Like we want to move from high pressure to low pressure.
Definitely.
And so air does the same thing, and it moves into the lungs, and that's when you have that inflation happening. And when you let go, it relaxes and allows air to be forced out back into the space where there's less pressure.
Wow, it's amazing how just this sort of membrane at the bottom makes this work. You really understand how the diaphragm that goes across the bottom of the rib cage can really help with our lungs. Amazing. So that's our basic model to try to understand that cool organ called the diaphragm.
Yeah.
So now we're gonna get into an actual lung model, right? Yes. Okay, so we've done our sort of just single diaphragm model, and now we have to go back to the trachea, the windpipe. So that's what you said, that is where air goes from the outside into our lungs. And what's the sort of trachea and windpipe, what's that shaped like?
So you can call it more like a fork, I guess.
Oh, okay, or like a Y?
Like a Y,
Sweet.
yes.
Okay, so I guess that must be what our 3 balloons are for, or our 3 straws. So we've got 3 straws, even though we just have the one windpipe, and that's because, like Chimuemwe says, the windpipe splits off of forks to go to one of each lung. So we are going to take 2 of our straws, and we're going to cut a little less than half of the straw. I'm going to do about this much. It doesn't need to be a particular amount. And then we are going to cut angles into one end of each of those short bits that we just cut off. So I'm going to cut it so that it's kind of pointed instead of being just straight off. This is all just to help us make this branching system known as our trachea. So I've got our 2 sort of evened off sections, and then this is our main windpipe. This can be longer because it's going to stick out the top anyway. And I want to cut the same thing. Instead of cutting just one angle, I'm going to cut 2, so that we're going to cut sort of a point here. Perfect. So we've cut the top of our straws so that they're all sort of pointy now, and they can all fit together. So what we're going to do next is we're going to connect all 3 together using tape to make this sort of Y section. But the reason we cut these slits is to try to make sure that air can still travel through all 3 straws, which are going to act as one. So now, all right, let's start taping it. I'm going to ask you to, let's see, can you hold this? And I'm gonna put maybe just 1 first. I'll put 1 on one side and then 1 on the other.
Sounds good.
So this might take a little bit of experimentation, scientists, because you might need to see what works to keep it airtight. So I'll hold one and then I'm going to put this one here. And do you think you could wrap that tape around? Or help me wrap that tape around? There we go. All right.
All right.
Let's do it.
Let's do it. Just gonna try this way first. I feel like it needs to go through. Right. More.
And now we're going to do that exact same thing with the other. And while we're working on this, Chimwemwe, can you tell me a little bit about your background and lungs, how that all comes together?
Yeah, so after I graduated from college with a biology degree, I went and worked for 2 years for a company that makes medicines for people with lung diseases, such as asthma, for example. And so I did that for 2 years, and then after that I decided to go back to school, where I went and got my doctorate degree in biology, and there I focused my work on lung biology, kind of understanding how everything that we breathe in, things like, viruses or like dust particles, can affect our lungs and lead to different diseases.
That makes a lot of sense. Earlier today, T was talking about that going around, that her lungs are a little bit irritated by the air. So that's amazing. I'm so glad that people like you are studying this and keeping our lungs healthy.
Yeah.
So now we've got our model. We've got what is sort of set up. So our next move is going to be to put all of this in a water bottle. Now you can take the bottom of your diaphragm off and do that, but hopefully if you made this flexible enough, you should be able to put both lungs in through the top of the water bottle, even with your diaphragm still on. But if you need to remove the diaphragm from the bottom and put the straw through the bottom, that will work too. So we're going to get our lung model into the water bottle. Oh,
Perfect.
okay. So we've got it in here, into this water bottle, and now we have to make the top airtight. Gotta make sure that, as Chimwemwe was saying, we gotta get that pressure difference right. There's more pressure outside, less pressure inside. We gotta keep that air pressure. So because we don't want to cut a hole in the lid of the bottle or anything like that, we're just going to use good old-fashioned Play-Doh. Model Magic will work. Any clay would do. And we're going to put it around, put it through this, let the straw go through, and then we're just going to mash it up until we have what feels like a pretty good seal around the top of the bottle. I'll hold this up. I want to make sure that we can see the lungs. All right. So kind of got this all here, got this sticking out. So I guess if this were if this were my body, the diaphragm would be here, there's the rib cage, and here's the trachea, and then out at the top would be where the air comes in, our mouth or our nose, right? All right, so would you like to do the honors?
Sure, we can
hold down our diaphragm and see how it works.
Okay, let's go. So must have a leak somewhere. Let's try again.
So we'll try again. I'm gonna try doing it inside too. This is the one part you kind of just can't test in advance. You just have to do it till it works. Okay. So if the balloons don't inflate, that means there must be some air escaping somewhere. So we're gonna try again with this. All right, let's see. Oh, I see some expansion.
Yeah, I see that too.
Okay, so I'm gonna try to pull a little more out like this. Keep it a little contracted. Okay, let's try one more time.
Try it, okay?
Whoa, okay, now I can see. There goes purple. Yeah,
yep.
Again. Whoa.
Wow. All right, and then I let go.
Cool.
So breathe in and breathe out.
So when you're breathing in, that's when your diaphragm is pulling?
Yes, exactly.
Wow, is anyone else thinking about their breathing right now? I am. So as you pull down, leaving room in your lungs, how much room is there in our lungs?
So we can think of it as the surface area being equal to about the size of a tennis court.
Wow, so the inside of our lungs have all kinds of bumps and ridges and surfaces to help do what?
To help, so the goal is to help us breathe in a gas called oxygen that all of our cells in our body need to create energy, and we have to breathe out carbon dioxide, which is a bad gas that our body does not need.
Wow, so as we breathe in, we're pulling in that oxygen and it's going through our lungs to get to the rest of our body, to our blood, to our brain, to our heart, all of those great things. And so if you're really working hard, if you're running and the breathing really hard, does that mean the diaphragm is moving more?
Exactly. So because the body wants to make up for you exercising, it wants you to make to keep breathing, and so you're gonna have that movement more frequently than normal.
Cool. And what are some ways that the lungs can work a little bit not so well? How are some ways that diseases or other things can hurt our lungs?
Yeah, so you may all know by now about COVID. So that's one of the main things that we know about now, caused by viruses that can affect how our lungs function. But there are also other diseases that people are born with or that they might develop later on in age due to like being exposed to different things that are in the air. So some of these diseases, the things like asthma as well.
Wow. Okay. So, and I know some people who have asthma who are able to use different materials that can help their lungs to breathe. And probably understanding the lungs really helps us to do that, huh?
Exactly.
Amazing. Well, I loved building this model of a rib cage. All right, and that is our lung model.
This is so cool. It's like I'm holding lungs in my own hands.
Wow, that is a strange yet intriguing thought. So I think that this has been a really, really great experiment. Thank you so much for bringing it today.
Yeah, no, I really enjoyed doing this experiment with you, so thank you for inviting me.
I learned so much. All right.
Hey young scientists, it's Dr. Sally, and today I'm going to do an interview with Giacomo Chiesi, the head of global rare diseases at the Chiesi Group. Let's see how our conversation went. Hi Giacomo, it's so cool to meet you. So I have a couple of questions for you today. When was Chiesi found and by who?
Chiesi was founded in 1935, and it was founded by Giacomo Chiesi, who happens to be my grandfather.
Thanks for telling our young scientists about that, Giacomo. What kinds of medications does Chiesi provide for their patients?
Chiesi provides medications to patients around the world in 3 different areas. The first one is pulmonary, so you can think of conditions such as asthma or chronic bronchitis. The second area is acute heart diseases such as hypertension and neonatal diseases such as diseases of premature babies. And the third area is rare diseases that are typically genetic in nature.
How do you find new medications for your patients?
We find medications for patients in 2 different ways. The first one is by developing those medications ourselves. And the second one is by collaborating with academic institutions and other biopharmaceutical companies to develop new medications.
Wow, Giacomo, it was so nice to meet you. Thanks for doing this interview for our young scientists.
Nice to meet you too. Bye, Dr. Sally, and have a great trip.
Thanks for setting me up with that experiment, Esther and Karina. We had so much fun and it was great getting to know Giacomo.
I am glad that you enjoyed the experiment with our colleague Chimwewe. And we love showing you around Parma.
Tamti, where are you off next?
Well, according to the SCU app, we're going to Hawaii!
Oh, that's so exciting!
Make sure you breathe well.
And remember, anyone can be a scientist.
Thank you so much. Okay, well, I need to get to the airport. Wait a minute. Where's Sarah?
Page